In the last lecture, we learned how to pass static data. Now let's say we have some dynamic data we have to fetch before a route can be displayed or can be rendered. For example, here on the servers. Let's say the servers already have been loaded. But once we click a server here, and maybe I should log in to demonstrate this, I want to load the individual server from some backend. So we are going to simulate that this takes a couple of milliseconds or seconds. So how could this work? If we have such a use case, we need a resolver. This also is a service just like can activate or can deactivate, which will allow us to run some code before a route is rendered. Now the difference to can activate is that the resolver will not decide whether this route should be rendered or not, whether the component should be loaded or not. The resolver will always render the component in the end, but it will do some preloading, you could say. It will fetch some data the component will then need later on. Of course, the alternative is to render the component or the target page instantly, and in the onInit method of this page, you could then fetch the data and display some spinner whilst you're doing so. So that is an alternative. But if you want to load it before actually displaying the route, this is how you would add such a resolver. So let's say for the single server here, I will add it in the server file, my server resolver. And again, this will be technically just be a service. So I'll export my class here, which I'll name server resolver. And now this has to implement the resolve interface provided by @Angular router. Resolve is a generic type and it should wrap whichever item or data field you will get here, will fetch here in the end. So we will fetch a server here, and therefore we should define the type here. Now you could outsource this into an interface or a model in general. So we will know that a server will have an ID which is of type number, that it will have a name which is a string, and a status which is a string. So this is simply a type definition of, well, the thing this resolver will give us in the end, to what it will resolve in the end. Now, the resolve interface requires us to implement the resolve method, and this resolve method here now takes two arguments: the route, so the activated route snapshot, which you already know, which you need to import from @Angular core, and it will also provide us the state snapshot, so the router state snapshot, which also needs to be imported from @Angular router. These are the two information pieces the resolve method gets by Angular. And in the end, this then also has to return either an observable, which you need to import from RxJS observable. This observable will then also return this type here. So we can copy this, but since we're creating a lot of overhead here, we can also quickly define an interface here. And it would, of course, be better to outsource this in its own file, but let's quickly do it here. So the interface for the server, which has an ID of type number, and then the name, which is a string, and the status, which is a string. And now this allows us to simply use server here as a shortcut for this type. So the observable should in the end give us back such a server, or we get a promise, which in the end will return such a server, or, well, just such a server synchronously. So this is what we will get back here in resolve. So now we need to implement the logic to get this back. Now we have our server's service here. And there we have the get server method, which will give us back a server. Now this clearly is some synchronous code. It will run instantly here. So there is nothing wrong with this code. We will resolve this instantly. And as you saw in your resolver, that's fine. One return possibility is to instantly return the data. So the easiest thing we can do here is reach out to our server service. And for this, we need to inject it. So we should provide our server service like this. That's a real hard word for me. Server's service like this. And of course, if you want to inject a service into another service, you have to add injectable to it. Make sure to import this from @AngularCore. Also make sure to import your own service. And with this, the easiest way to use this resolve function is to reach out to your service, and there we call getServer, and now we need to know the ID of the server we have to fetch. Because that is what we do in the server component here in the end, right? There in on init we're getting this server right now. So now we want to outsource this because let's say we want to do it before it loads. The good thing is we do get the route here. It only is the snapshot, but this service here will actually run on each time we re-render the route. So the snapshot is all we need. Unlike the component itself, again, this is executed each time. So no need to set up an observable or something like that. So here we can access our route, and there are the params, and then the ID, and make sure to cast it with a plus sign in front of it to an integer. This is the easiest way of using this resolver, which will do the loading of our data in advance. And now this would also work if this were to return an observable or a promise, so with asynchronous code, for example, an HTTP request. So this is our resolver. With this resolver in place, we of course now have to add it. So first thing is, in app module, we should add it to our providers, our server resolver, like this. Make sure to also add the import at the top. And with that added now, we want to add it to our routing module. Here, for the route where we want to use it, so let's say for this component here, we add another property, the resolve property. This takes a JavaScript object, and here we map all the resolvers. This is different to the other guards. There we used arrays, but for resolve a different approach is taken, and you will see why in a second. So here we have key value pairs of the resolvers we want to use. So for the server, and this name of the property is totally up to you, we will use our server resolver. Like this. Make sure to import it here at the top. This will now map the data this resolver gives us back. And remember, it gives us back some data with this resolve method it had to implement. This method will be called by Angular when this route is loaded. So the data it gives us back here will be stored in this server object we will then have available, or in the server property we will have available in this to be loaded component. So in this to be loaded component, in our server component, right now we get the server like this, using the params. Well, I will comment this out, because now we use a resolver for this. That's the goal of the resolver, and it makes even more sense if this is some asynchronous task, of course. So here, we can easily get our server by binding the data observable. So just like static data, which you passed with this data object here, with this data property you could add to a route, the data returned by your resolver will also go into this data baggage, in this data object you have in your to be loaded component. So here we can listen to any changes, and I'm setting up an observable here, or I'm using the observable here, I should say, because the server can change while we already are on the page, as we have this side menu. This is why we also had to set up our route params here dynamically. And here we know we will get back our data of type data as learned before. Make sure to import data from Angular router. And now we know that we can simply assign our server the server property in this component by binding to data server. And now this name here is important. This server here, this name here, of course, has to match the name you use here when you assign your resolver to some property. So if you change the name here, you have to change it when you retrieve the data. Well, with this in place, if we save this with ngserve still running, if we log in and go to servers and we click on a server, you see this still works as intended. It still loads the server like before, but now not using the params here in the server component, but instead using a resolver before this. Again, of course, especially important when using asynchronous data. almost done. We covered a lot in this module. This has been a very long section in this course, but it has been so important because routing is such a key task in any application. Now, if you have a look at our application, we got a couple of routes in there, /users, /servers, and much more. Now here's one important thing. It works fine here on our local setup, but actually this is not something you should take for granted. If you have a route like this, your domain /servers, and you're hosting this on a real server somewhere in the web, this might not work out of the box because their routes, the URL, is always, this is how the web works, is always parsed, handled by the server first, so by the server which hosts your application. Now here on the local environment, in our development environment, we're also using a development server, but this server has one special configuration your real life server also has to have. And I will come back to this in the deployment section. The server hosting your Angular single page application has to be configured such that in a case of a 404 error, it returns the index.html file, so the file starting and containing your Angular app. Why? Because as I mentioned, all your URLs are parsed by the server first. So not by Angular, by the server. Now if you have /servers here, it will look for a /servers route on your server, on the real server hosting your web app. Now chances are you don't have the route here because you only have one file there, index.html, containing your Angular app. And you want Angular to take over and to parse this route, but it will never get a chance if your server, the server hosting your app, decides, no, I don't know that route, here's your 404 error page. Therefore, you need to make sure that in such a case, your web server returns the index.html file. If for some reason you can't get this to work, or you need to support very old browsers which are not able to parse paths like this in the client, which Angular does then, you have an alternative approach to using these nice URLs which look like all URLs in the web. You can fall back to our older technique which was used a couple of years ago, using a hash sign in your routes. Let's see how we enable it, and then I will explain what it does. You can enable it in your app routing module, where you register your routes here with the for_route method. You can pass a second argument, a JavaScript object, to this method, configuring the setup of your routes. So besides the routes itself, now we can configure them. And one important configuration is the use hash configuration, which you can set to true. The default is false, which is why we didn't have to pass it. If we do this and we save that, let's see what happens. You out of the box see that now we have this hashtag in our URL. And if I click on servers, you see there is this hashtag in between. And that's no bug, that belongs here because this is this hash mode routing. What this hashtag will do is it informs your web server, hey, only care about the part in this URL before this hashtag. So all the part thereafter will be ignored by your web server. Therefore, this will run even on servers which don't return the index.html file in case of 404 errors, because they will only care about the part in front of the hashtag. That's how it works by default. And the part after the hashtag can now be parsed by your client, by Angular. So this is the solution if you can't get the other approach to work. However, I will say that definitely you should try to use the more prettier routes using the HTML history mode, as it is called, with the normal / routes without the hashtag. So this is how you would enable it. I'm going to duplicate this, so to comment this out, to have it there for reference, but I will fall back to the other mode, which gives us cleaner routes, which really look a lot nicer and more like you're used to seeing routes from other web apps. And this is the last piece of this section.